So, I wanted to cover a bit about how the CPU, sort of the central processing unit of a computer, works. And now, what is a central processing unit? A central processing unit is sort of, if you imagine the brain of the computer, um, and to really understand what it does, we first need to understand what a program is. And a program at its basis, like everything that runs on your computer is a program, from like Windows to the sort of BIOS in it, which we'll get to at some other point. But sort of every piece of software that runs on your computer is a program. But that really doesn't answer the question of what a program is. And so let's have a look at a program in a format that we call assembly. And now, we've covered algorithms, where an algorithm is a series of steps in a specific order. And a program is essentially an algorithm, but more specific to the computer. And what I mean by that is that a CPU executes instructions in an order. It's like following the recipe of the program in an order, but there's only like a specific like number of different instructions or like things that the CPU can do. And the program is essentially, and we call those one of those things like an instruction. For example, in this program here, we can see MOV is an instruction, or sub is an instruction, or add is an instruction. And so a series of programs is a program is a series of these instructions executed in a specific order. And you can see that sort of here. So in this program, we'd sort of execute this instruction, this mov r1 r0 instruction, and then we'd go to this instruction. Ignore the main loop bit here. That's to do with branching, which is a different concept. But then we'd do this instruction, mov r3 r4 r1, and then mov r1 r7 4. And so on, and we'd go like, depending on this branch thing, we'll then go on. Okay, we move on to this instruction: sub r2 r6 r0, and so on. And so this is essentially what a program is a series of these specific instructions that the CPU can understand, executed in a certain order. And that order will include branching. For example, these branch instructions sort of make the program jump to a different like place in the program. So this branch square one will jump to like this section here. We'll make the program jump there. And so when a program is sort of actually running on a computer, it's stored in what we call memory, which is you might have heard like RAM, which means random access memory, which is typically what is used in a computers these days. But imagine sort of memory as like a long tape, and in that tape there are like, it has sort of individual spots which are numbered, and each of these spots can hold a value or an instruction. And so once they're assembled, like and sort of in memory, the instructions of the program will be sort of stored in order. So for example, we can see if we click on this memory location here and I drag this here. So this is our memory location 0, and you can see sort of this, the instruction stored here is the same as this first instruction here. If we click on the second one here, we get these instructions here stored in order. Sort of, you can see this is the second memory location. We're starting counting at 0, so this is the second one. But you can see here we've stored, it corresponds to the second line there. And if we go on to the third memory location here, we can see that's corresponding to that third line as well. So you can see sort of we have this memory that stores the instructions we want to the CPU to execute, to carry out in order. The way that this works in the CPU is sort of what we call the fetch execute cycle, which is the cycle where we sort of fetch the next instruction in the program, then we execute that instruction, and then we fetch the next one, execute that one, fetch the next one, execute that one, and so on and so forth.